All right, we have 1a. We have 1/2 square root 45. So we're going to take 45 off to the right and do a prime factorization tree. So 45, and that's going to be 9 times 5, and that's going to be 3 times 3. So we can take the answer, we can start by saying 1/2, we haven't touched that yet. And then root 45 is simply on the top 3 root 5. Good, so what do we do with the 1/2 and the 3 out in front? Well, we multiply them together. We can simply multiply fractions to get 3 over 2 root 5. Let's circle our answer. So now we're going to check our answer. We're going to type the question into the calculator. So if I type in 1/2 square root 45, up near the answer, up near the question equals, near the question first, equals 3.35. And then if I type in the answer, 3 over 2 square root 5, I get the same answer, equals 3.35, check mark. So we're not going to keep checking our answer. You just know that you know how. If any of this basic stuff is difficult for you, we're going to go back to previous years and we're going to study radicals from grade 10. If it's not, we'll continue. Okay. Okay, we have 1b. This is 2x square root 125 x to the 5. So let's clean up that 5 a bit. So off to the right, let's do a prime factorization tree on 125. So 125, and down the page we're going to have 25 times 5, and then we're going to have 5 times 5 again. And beside that, we're going to prime factorize the x to the 5, which no, we're not. It's just x times x times x times x times x. So let's clean it up. So let's say 2x, and then times 5 root 5, simplifying the root 25, and then we're going to simplify the x to the 5, which will be times, outside of the root, a separate root, x squared root x. Again, if that is difficult for you, go back and study radicals from grade 10. Okay, we can combine all the numbers in front. So we have 2 times 5 is 10, so we can say 10. Then we have x times x squared, so that's x cubed. Then we can multiply the things that are left underneath the root, root 5x, and circle our answer. Again, you could check your answer by picking an arbitrary value for x, like 3, substituting into the question and substituting in the answer and making sure that they're the same. But I've done that enough in grade 10, so go back and check all that, and then we should be good. Okay. Okay, we have 1c. We have the cube root of 189. So off to the right, we can do a prime factorization tree on 189. It's 27 times 7, and 27 is 9 times 3, and 9 is 3 times 3. So this time we're looking for triplets. So we have 3 3's, so it's simply going to be 3 root 7 with the cube root. Don't forget the cube root. Let's type this one into the calculator. So if I do the cube root of 189, I'm going to get near the question equals 5.73. And let's circle the answer. And near the answer, if I type in 3 cube root 7, I also get 5.73. Check mark. Awesome. Okay, we have 1d. This is a 2-line square root of 1 over 16. So 1 over 16 and a square root over the whole thing, called a 2-line root. So we can go to the right, we can say equals root 1 over root 16, separating the roots, equals, the square root of 1 is 1, and the square root of 16 is 4. Circle our answer. So on the calculator, if I type in the square root of 1 over 16, I get 0.25 near the question, maybe below it. We'll say 0.25, and the answer is also 0.25. Check mark. Awesome. Okay, we have 1e. We have the square root of 0.04. So 0.04 as a fraction is 4 over 100, so we can say equals 4 over 100 and put a 2-line square root over it. Then let's go to the right and let's separate it into root 4 over root 100. And again to the right equals 2 over 10. The square root of 4 is 2. The square root of 100 is 10. We can simplify this fraction. Equals 1 over 5. Circle our answer. Okay, so if I type in the question, square root of 0.04 near the question, we can say equals 0.2. And if I type in the answer, 1 divided by 5 near the answer, 0.2, check mark. All right. Okay, we have 1f. So we have the square root of 12 over the square root of 6. So, just like before, we've separated a root into 2 roots. Now we're going to combine it into 1 root. So we can say equals 12 over 6 in a single root. Now, 12 divided by 6 is simply 2, so we can say 2 and put a square root over it and circle our answer. Now, if I type the question into the calculator, near the question, we can say equals 1.41. And near the answer, we can say equals 1.41, typing root 2 into the calculator and root 12 over root 6 into the calculator. They're both 1.41, so we know they're correct. Okay, we have 2a. So we have the question x squared equals 9. Now to reverse a squared, we simply square root both sides. So the answer is x equals plus minus 3. We have to include plus minus 3. So let's check this. Let's circle our answer. And then off to the right, let's check our answer. So back up at the top, brackets around it, 3 brackets. Oh, off to the right, 3 brackets around it squared equals 9. And also open bracket, negative 3 close bracket squared also equals 9. So we can put a check mark beside our answer and we're good. Okay, we have 2b. So we have x squared plus 100 equals 0. So let's subtract 100 from both sides. And we have x squared equals negative 100. Let's square root both sides. Now, can we square root a negative? No, no solution. The easiest question on the test. We cannot square root a negative. If the thing that you're looking for, if the method that you're trying to use does not work, then the thing that you're looking for does not exist. All right, we have 2c. X cubed equals negative 64. So this time we have a cube root. We're going to have to cube root both sides. So on the left-hand side, the cube root of x cubed is simply x. And on the right-hand side, the cube root of negative 64 is what? Off to the right, let's do a prime factorization tree on 64. So let's go for 4 and 16. And 16 is 4 times 4. So this is the easiest way. We can see that it's 4 times 4 times 4. So the answer is simply negative 4. Circle our answer. Perfect. So now if we cube negative 64, off to the right, open bracket, negative 4 cubed equals, on the calculator, negative 64. Near our circled answer, check mark. Awesome. All right, we have 2D. We have x squared equals 3. So we're simply going to square root both sides. And x equals plus minus root 3. Let's circle our answer. That's it. That's the answer. We don't have to square root it. We could, if your teacher asks for a decimal, we could give them a decimal answer, but that is the answer. Just square rooting both sides and recognizing that even though it's a funny looking answer, that's still the correct answer. Okay. Yep. Lots of space. Okay, so let's do 2e. So a little bit off to the right, we have x to the 3 over 2 equals 8. So we have a fractional exponent. In order to get rid of a fractional exponent, we have to take both sides to the reciprocal of that exponent. So brackets around the left-hand side, the whole thing, to the 2/3. On the right-hand side, brackets around the right-hand side to the 2/3. On the left-hand side, we can simply cross out both exponents together, and down the page, x equals. So we're going to convert this into a root. So again, remember, review your grade 10 radical rules, but this is the cube root of 8 squared. So we can say cube root 8 squared. Down the page, x equals. So do we want to square it first or take the cube root first? We want to take the cube root always if we can. The cube root of 8 is 2, so we can say 2 squared. And down the page, x equals 4. Circle our answer, and let's check our answer. So off to the right, let's say 4 to the 3 over 2. On the calculator, 4 to the 3 over 2 equals 8, equals 8. Near our circled answer, check mark. Awesome. Okay, we have 3a. So we have 7 square root 2. Good. Now, we simply want to just put 2 7s on the inside. So down the page, we'll say root 7 times 7 times 2. So 7 times 7 times 2 is simply 98, so we get square root of 98. And we can circle our answer. Near the question, we can say equals, if I type it in the calculator, 9.90. And near the answer, square root of 98, also 9.90, rounded answers, making sure those are correct. Awesome. Okay, we have 3b. So this is -3 cube root 6. So this time we're going to put 3 things in. And remember, we're allowed to put negatives into a cube root. So we're going to say the cube root of -3 times -3 times -3 times 6. So we can say the cube root of, we have 3 negatives, so this answer is going to be negative. So negative, and 3 times 3 times 3 times 6 is 162. Circle our answer. Feel free to check those answers on your own. Okay, we have 3c. So this is 3 over 2, x on the top, cube root of 8x. So we're going to have to put 3 over 2x on the inside 3 times. So let's do a big 2-line cube root. Cube root. Good, so 3 over 2x times 3 over 2x times 3 over 2x times 8x. So we'll notice, well, down the page, let's start by setting up our cube root. So cube root. And 3 times 3 times 3 is 27, so we'll have 27. Then we have x to the 4. x to the 4. Now, we have 2 times 2 times 2 on the bottom. 2 times 2 times 2 is 8, but we also have an 8 on the top. We're just going to cancel the 8 and cancel all the 2's. And there is our final answer. Combining roots into a single root. We can circle our answer. So this is a much more unlikely case where we combine the roots. We usually simplify the roots and go in the opposite direction, as we did in the first question. But keep in mind, go back to grade 10, learn how to do radicals, because this is going to get a lot harder. Okay. Okay, we have 4a. This is 10 square root 5x times 3 square root 7. So all we're going to do is multiply the numbers in front and multiply the numbers underneath the root. 10 times 3 is 30, so we have 30 square root 35x. Now, we would think, can you simplify 35? No, because we multiplied 2 prime numbers together to get it, so we can't simplify it. Let's circle our answer. Okay. Okay, we have 4b. We have 9 times 3 root 2. So this is just a little idiosyncrasy. the last question, we multiply the numbers in front and we multiply the numbers underneath the root. In this question, we're going to do exactly the same thing. We're going to multiply the numbers in front and multiply the numbers underneath the root. 9 times 3 is 27. Now we just say root 2. Circle our answer. So again, check your answer by typing it into typing the question into your calculator, typing the answer into your calculator, making sure that they're the same. We're just covering this little idiosyncrasy. All right. We have 4C. So this is going to be open bracket 3 square root 2 close bracket squared. So we're going to square both things. 3 squared is 9, open bracket, root 2 squared is 2. And 9 times 2 is simply 18. Circle our answer. Okay, we have 4D. We have 7 cube root 3 times 2 cube root 5. So as we learned earlier, we just multiply the numbers in front and multiply the numbers underneath. 7 times 2 is 14 cube root. 3 times 5 is 15. Circle our answer. We know we can't simplify it further because we multiplied prime numbers to get it. So again, check your answer on your calculator and just remember, they have to be the same type of root in order to multiply them. We're just going to close that bracket in the question that we've forgotten to close that bracket just so it looks a little bit more normal. Sorry about that. Awesome. Okay, we have 4E. So we have 9 cube root 5 times 3 square root 7. So in the last question, I reminded you that you couldn't multiply roots together that were not the same type of root. But we can still multiply the coefficients. 9 times 3 is 27, and we're just going to say cube root 5, square root 7, circle your answer. We can't multiply different indexes together. Okay. Okay, we have 4F. So we have the square root of 3 squared. So the square and the square root just cancel each other, equals 3. Circle your answer. So that was just a little question to just show you, make you thinking the way we want to be thinking in radicals. A square root cancels a squared. Okay. Okay, we have 4G. So we have open bracket, square root x minus 999 underneath the root, close bracket, squared. So again, we just learned in the last question that something root something squared is just that something. So the answer is simply x minus 999. Circle your answer. Sometimes we're just doing this, so when we do harder questions in the future, we're going to be right on top of it. Okay. Okay, we have 4H. So we have open bracket 2 root x minus 1, all under the root, close bracket squared. So we have to square the 2 and we have to square root that. So we're going to say 4 open bracket x minus 1. Then we're going to distribute the 4. We're going to get 4x minus 4. Now both answers are good, so let's circle both answers together. One's in factored form, one's in standard form. They're all good. Just making sure that you understand root that squared just doesn't mean just that. You have to still consider all of the other things. Great. Okay, we have 4I. We have 2 root 7, open bracket, 3 root 6, separately plus root 2, close bracket. So let's put some distribution arrows from our 2 root 7 into both things. So we're going to multiply the numbers in front and multiply the numbers underneath the root. So we're going to get 6 root 42 plus 2 root 14 and circle our answer. We know that we multiplied numbers together that can't be simplified to further prime factors, so that is our final answer. All right. Okay, we have 4J. We have open bracket, root 2 plus root 3, close bracket, open bracket, root 6 plus root 2. So now we're going to FOIL it out. So 2 lines above, 1, 2, and 2 lines below, 1, 2. There are FOIL lines. So first to the first to the outside. Good. Great. So first to the first will be root 12. Root 2 times root 6 is root 12. Then we have root 2 times root 2, which is root 4, which is just 2. Then we have plus root 18. Then we have plus root 6. So we can simplify these. Again, if you have difficulty simplifying these, go back to grade 10 and learn how to simplify these. But either way, root 12 is simply 2 root 3 plus 2 plus 3 root 2 plus root 6. Now, none of these are like terms, so we can't add or subtract any of them. Let's circle our answer. All right. Okay, we have 4k. Open bracket, root 7 plus root 5. Close bracket, times root 7 minus root 5. So we're going to FOIL it out. Root 7 times root 7 is simply 7. Minus root 35 plus root 35 minus root 5 times root 5 is simply 5. The negative root 35 plus root 35 cancel, and we're simply left with 7 minus 5, which is simply equal to 2. Circle our answer. Awesome. Okay, we have 4m. We have a fraction. On the top, we have 8 root 18 over 4 root 2. So we can divide the numbers in front. 8 divided by 4 is simply 2. Good. Now we can turn it into a single root. Down the page, we can say 2. And now we're going to have a 2-line root. So we're going to have, beside it, we're going to have root 18 over 2. 18 divided by 2 is simply 9. So we're going to be left with 2 root 9. Root 9 is 3. So we have 2 times 3 is 6. Circle our answer. Awesome. Okay, we have 4m. Excuse me, I called the last question m. It was L. This is m. So we have a fraction. We have 8 square root 6x cubed over 4 square root 2x. Again, we can simplify the numbers in front. So 8 divided by 4 is simply 2. Then down the page, we can say 2. We can set up a 2-line root. And we can say 6x cubed over 2x. We can then combine these. So down the page, we can say 2 root. So 6 divided by 2 is 3. And x cubed divided by x is x squared. So now we can further simplify it because we have x squared on the inside. That's simply going to be 2x root 3. Circle our answer. So if we have x squared, that's x times x. That means we have 2 x's on the inside of a square root. Bring 1 out. Go back to grade 10 and learn more about simplifying radicals. Okay. Okay, we have 5a. We have square root 12 plus 2 root 3. So square root 12 simplifies to be 2 root 3 plus 2 root 3 equals 4 root 3. Let's check this on the calculator. So if I type it on the calculator, square root 12 plus 2 square root 3, near the question we get 6.93. And then if we circle our answer, 4 root 3, if I type in 4 root 3, we get the same answer, 6.93, near our circled answer check mark. Nice. Okay, we have 5b. We have 2 root 12 minus 1 root 75. That 1 is unnecessary. Okay, so we're going to simplify root 12. So we're going to say 2 times 2 root 3 minus, now 75 is simply 25 times 3, so that's 5 times 5 times 3, so it's simply 5 root 3. So we can clean this up. We have 4 root 3, 2 times 2 is 4, 4 root 3 minus 5 root 3 equals negative root 3 or negative 1 root 3. Circle our answer. Feel free to type that into the calculator to make sure that it is correct. Okay. Okay, we have 5C. We have 1/2 square root 28 plus 3 square root 63 minus 2. Okay, so root 28 is simply 4 times 7, which is simply 2 root 7. So we have 2 root 7. We can put 1/2 out in front. Plus, so root 63 is 9 times 7. So that's 3 root, so we have 3 times 3 root 7, all minus 2. So we can multiply the fraction by 2. 1/2 times 2 is simply 1. So we just simply have root 7 plus 3 times 3 is 9. We have 9 root 7, all minus 2. So if we have 1 root 7 plus 9 root 7, we have 10 root 7, all minus 2. And let's circle our answer. We can't combine those any further. Great. All right, we have 5D. We have 2x root 20x. And we have plus 3 root 45x cubed. So we can simplify these roots. So it's going to be 2x times. So root 20 is 4 times 5, so that's 2 root 5. X underneath, close bracket, plus 3 times. So 45 is going to be 3 root 5, so times 3 root 5. And then if we simplify the x cubed, we're going to get 3x root 5x. Again, go back to grade 10 to make sure that you're absolute ninja at those. Okay, we can multiply our numbers in front. So we have 2x times 2, which is 4x root 5x, plus 9x root 5x. So we have the same type of root, so we can simply simplify the coefficients if we can. 4x plus 9x is 13x root 5x. Circle our answer. Awesome. Okay, we have 6a. Find the restrictions. Square root x plus 2. So beside it, let's say x plus 2 greater than equal to 0. Let's minus 2 from both sides. Minus 2 minus 2. X needs to be greater than equal to -2. Circle our answer. So these restrictions we're setting up for building up to do solving equations, making sure we always state our restrictions. Okay, 6b. We have square root 2x minus 3. So off to the right, we can say 2x minus 3 greater than or equal to 0. We can't square root negative, so underneath the root needs to be greater than or equal to 0. We can add 3 to both sides, plus 3 plus 3. Ooh, we've just done it in our heads. Nice work. So we're going to be skipping steps all the time because your teachers are going to start to, and you have to start getting ready to skip algebraic steps. Let's divide both sides by 2 over 2 over 2. X is greater than or equal to 3 over 2 or 1.5. Circle our answer. Great. Okay, 6c. We have the square root of 3 minus x. Off to the right, 3 minus x greater than equal to 0. Let's minus 3 from both sides. Good. Negative x is greater than or equal to -3. Divide both sides by -1. X needs to be less than or equal to +3. Circle our answer. Notice we multiplied or divided by -1, so we have to change the direction of the sign. Okay. Okay, we have 7a. Square root x minus 2 equals 6. So we're going to add 2 to both sides, so plus 2, and root x equals 8. Then we're going to put brackets around the left-hand side, squared. Brackets around the right-hand side, squared, to get rid of our square root. X equals 64. Circle our answer. We're then going to take our answer and put it back into the question from above. Square root 64 minus 2 equals 6. The square root of 64 is 8. 8 minus 2 equals 6. Check mark. Yeah, so just remember the equation came from above. We take the value that we got and put it back into the equation from above. Okay, we have 7b. We have the square root of x plus 8 equals 6. So let's minus 8 from both sides. Minus 8 minus 8. Then we have square root 8 equals, square root x equals negative 2. Let's square both sides. Brackets around the left-hand side squared. Brackets around the right-hand side squared. So we get x equals, the square root of this x, negative 2 all squared is 4. Circle our answer. Take our answer and put it back in above. So square root 4 all plus 8 equals 6. The square root of 4 is 2. Plus 8 equals 6. And 2 plus 8 is 10. So 10 is not equal to 6. X. So something was wrong. What was wrong? Well, let's take that third line off to the right. Root x equals negative 2. A square root can't equal a negative. So if you ever get to this point, you just say no solution, rather than bothering solving and checking your answer to make sure. We just know that there's no solution. All right. Okay, we have 7c. We have root x equals root 6 minus x underneath the square root. Good, so brackets around the left-hand side squared, brackets around the right-hand side squared, and we'll get x equals 6 minus x. So if we add x to both sides, plus x, we'll get 2x equals 6, and we'll divide both sides by 2, and x equals 3. Circle our answer. We can take that and put it back into the question. Root 3 equals root 6 minus 3. 6 minus 3 is 3, so we can say root 3 equals root 3. Check mark. Awesome. Okay, we have 7d. So we have 2 square root x plus 4 equals 4. So we could square both sides, but we'd rather divide both sides by 2. Over 2 over 2. On the left-hand side, we can cross out the 2's, and we can say root x plus 4 equals 2. We can then square both sides. Brackets around the left-hand side squared. Brackets around the right-hand side squared. On the left-hand side, we have x plus 4 equals 4. And we can minus 4 from both sides. X equals 0. Circle our answer. We can then take our answer and put it back into the question before we did anything to it. 2 square root 0 plus 4 equals 4. Good. 0 plus 4 is 4. So we have square root 4, which is 2 times 2, which is equal to 4. Check mark. Awesome. Okay, we have 7e. We have x equals square root 2x plus 3. So we're going to put brackets around the left-hand side and say squared, and brackets around the right-hand side squared. So we get x squared equals 2x plus 3. X, yeah, perfect, keep going. Good, so we get x squared, excuse me, equals 2x plus 3. Now, this is something from chapter 4, quadratic equations. We're going to get it equal to 0 by bringing the 2x and the 3 over. X squared minus 2x minus 3 equals 0. Again, if bringing it over is difficult for you, make sure that you show all your steps and minus 2x and minus 3 from both sides and get this. We're now going to factor it. It's going to factor to be x minus 3, x plus 1. These are two numbers that multiply together to make -3 and add together to make -2. We can then say x equals 3 and x equals -1. Again, make sure that if that process is difficult for you, go back to quadratic equations in chapter 4 and study those. Great, so we can circle both of our answers. Okay, perfect. Great. So now we're going to take our first answer 3 and substitute it back into the question before we squared both sides. 3 equals square root 2 times 3 plus 3. Good. We're going to get 3 equals the square root of 9, check mark. Okay, beside it, let's take -1. -1 equals root. Good. So, first things first, we know this answer does not work because we have a square root equaling a negative, but let's prove that. So down the page, -1 equals. So we have the square root of 2 times -1 is -2 plus 3 is going to be -1 equals the square root of 1. So -1 equals 1, which is not true, x. And we can cross out that solution in our circled answers above. Awesome. The only answer is x equals 3. Remember, check your answer every single time. And also remember to be stating your restrictions. We showed how to state restrictions in the last question. We're not going to keep doing it every single time, but you have to on a test. Make sure you check your answer every single time, no matter what. Great. Okay, we have 7f. We have 2x equals square root 7x minus 3. Okay, so we're going to brackets around the left-hand side squared, brackets around the right-hand side squared. So on the left-hand side, we have 4x squared. On the right-hand side, we have equals 7x minus 3. We're going to get this thing equal to 0. We have 4x squared minus 7x plus 3 equals 0. Off to the right, blank times blank equals 12, and below it, blank plus blank equals -7. The numbers that multiply together to make 12 and add to get 7 are 3 and 4, 3 and 4, 3 and 4, and both need to be negative in the addition statement. Put them in above, make sure the multiplication statement works, and we can separate. 4x squared minus 3x, minus 4x, all good, minus 3x plus 3, that order doesn't matter, equals 0. Good, so brackets around the first two terms. Do not cut off the negative. Brackets around the second two terms. And we're going to remove a greatest common factor, so we can take out a 4x. So 4x open, x minus 1 close. Then we're going to take out a -3 open, x minus 1 close, equals 0. Then we have a greatest common factor of x minus 1, so x minus 1 and 4x minus 3 equals 0. This time we're going to set our factors equal to 0 separately and solve. We have x minus 1 equals 0. And we have x equals 1, circle our answer, and 4x minus 3 equals 0. We're going to show all the steps for this one, adding 3 to both sides. 4x equals 3, and dividing both sides by 4, and x equals 3 over 4, circle our answer. Okay, now we're going to check our answer by putting them back in. So we have 2 times 1 equals square root 7 times 1 minus 3. So on the left-hand side, that's going to be 2. On the right-hand side, that's going to be the square root of 4, which is correct. Check mark. Okay, beside it, 2 times 3 over 4 equals root 7 times 3 over 4 minus 3. On the left-hand side, we get 3 over 2 by cross-canceling. And on the right-hand side, we get equals the square root of 2.25. And the square root of 2.25 is 1.5. So 3 over 2 equals 1.5 check mark, and this time we keep both answers. So just because it was a quadratic doesn't mean that we just reject both answers. We check both answers and figure out which one is correct. Okay. Okay, we have 7G. So we have square root x plus 3 to the right minus 1 equals x. So we want to isolate the root as we've done before. So we want to add 1 to both sides. Let's say root x plus 3 equals x plus 1. So we're going to square both sides. Brackets are on the left-hand side squared. Brackets are on the right-hand side squared. Down the page, we have x plus 3 equals x plus 1 times x plus 1. Brackets, 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 brackets. And we're going to FOIL out the right-hand side. Down the page, on the left, x plus 3 equals x squared plus 2x plus 1. We'll then get it equal to 0. 0 equals x squared plus x minus 2. Good. Again, if that stuff is difficult for you, go back to chapter 4 and learn how to bring stuff over, or go back to grade 8 and 9 and learn how to do algebra better. Okay, so we're going to factor it. Two numbers that multiply together to make negative 2 and add to get 1 are going to be x plus 2 and x minus 1 equals 0. And let's set our factors equal to 0 separately and show every single step this time, just because I'm thinking that students who have only seen this chapter before others will need to see these steps. So we're going to set our factors equal to 0 separately and solve. So side by side, good. And then if we minus 2 to both sides, we'll get x equals negative 2. And then if we add 1 to both sides, we'll get x equals 1. Circle our answer. Good. So now we're going to take those answers and put them back into the question. So we have the square root of negative 2 plus 3 all minus 1 equals negative 2. So negative 2 plus 3 is 1. The square root of 1 is 1. 1 minus 1 equals negative 2. Now 1 minus 1 is 0, so 0 doesn't equal negative 2. Let's put an x somewhere and let's cross out our answer. Let's try the other answer. So let's do it down below where we have space, down back on the margin. Sure. Square root of 1 plus 3, all minus 1 equals 1. 1 plus 3 is 4. The square root of 4 is 2. And the square root of 2 minus 1 equals 1. Check mark. We know that that is our only answer. X equals 1. Awesome. So lots of different types of doing these things. Make sure you isolate the root before you square both sides. And we're going to have to be doing factoring from a different chapter. Again, if you haven't done that chapter already, make sure you go and look at how to do some of those factoring methods in the beginning. Okay. Okay, we have 8a, rationalize the denominator. So we have 1 over root 5. In order to rationalize the denominator, we're going to multiply the top and the bottom by root 5. 1 times root 5 is simply root 5, and root 5 times root 5 is simply 5. Let's check our answer on the calculator. So circle our answer first of all. And if I type in 1 divided by square root 5 near the question, we can say 0.45. And then if I type in square root 5 divided by 5, we also get 0.45. Check mark. Awesome. Okay, we have 8b. We have 2 over root 2. Again, we're going to rationalize the denominator by multiplying the top and bottom by the root in the denominator. And we're going to be left with, on the top, 2 root 2 over root 2 times root 2 is simply 2. Now we have a 2 on the top and the bottom. We can cancel, and we can just say equals root 2 and circle our answer. Again, feel free to check your answer on the calculator by substituting, by typing it into the calculator, but I will let you do that on your own. Okay, we have 8c. 1 over 2 root 3. So we have a root 3 on the bottom. We're going to times the top and bottom by just root 3. And we're going to be left with root 3 over 2 times 3. Root 3 times root 3 is just 3. So we'll get root 3 over 6. Circle our answer. So for some reason, they want you to rationalize the denominator to get rid of the root on the bottom, because for some reason, it's easier to divide by an integer than a root. We're just rationalizing the denominator, getting rid of the root on the bottom. Okay. Okay, we have 8D. We have 5 over the cube root of 3. So we have to rationalize the denominator by multiplying the top and bottom by cube root 3 twice. So cube root 3 on the top and the bottom, and again cube root 3 on the top and the bottom. So again, remember, if it's a cube root, we have to multiply the top and the bottom by the cube root twice. So on the top, 5 times cube root 3 times cube root 3 is simply 5 cube root 9, which we can't simplify, over cube root 3 times cube root 3 times cube root 3 is just 3. Great, let's circle our answer. Perfect. Okay, we have 8E. 3 over 8E. We have 3 over square root 3 plus 1. So this time when we have a binomial on the bottom, 2 terms, we have to multiply the top and bottom by the conjugate, root 3 minus 1. So if it's plus on the bottom, we times the top and bottom by minus the conjugate. Okay, so we're going to distribute the top. So we're going to get 3 root 3 minus 3 over, now we're going to FOIL the bottom. We're going to do all the steps. Root 3 times root 3 is simply 3, minus root 3, plus root 3, minus 1. The middle 2 terms cancel, and we're going to get 3 root 3 minus 3 all over. 3 minus 1 is simply 2. So we can down the page say 3 root 3 minus 3 all over 2 and circle our answer. Again, remember, feel free to check your answer by typing the question into the calculator, typing the answer into the calculator, making sure that they're the same decimal, or else you did something incorrect. Great. Okay, we have 8F. On the top, we have 2 plus root 3 all over root 6 minus 1. We're going to times the top and bottom by the conjugate of the denominator, root 6 plus 1. Good. On the left, we're going to put brackets around the top and brackets around the bottom. And we're going to FOIL it out. We can erase that bracket below. So now we're going to FOIL it. So again, remember, any difficulty with FOIL, go back to the earlier questions and review them. Outside of that, on the top, we have 2 root 6 plus 2 plus root 18 plus root 3 all over. Root 6 times root 6 is 6 minus root 6 plus root 6 minus 1. The root 6's cancel, so we're left with 2 root 6 plus 2, hang tight. Root 18 simplifies to be 3 root 2 plus root 3 all over 6 minus 1 is simply 5, and none of the roots on the top combine, so we can circle our answer. So again, rationalize the denominator, either multiplying the top and bottom by the root in the denominator or multiplying the top and bottom by the conjugate of the root in the denominator. Okay. Okay, 8G. Rationalize the denominator and add. We have 10 over root 5 minus 6 over root 5 minus 2. All in the denominator. Good. So let's start by taking 10 root 5 off to the right and rationalizing it. 10 over root 5, excuse me. Times the top and bottom by root 5. So it's going to simplify to be 10 root 5 over 5 and 10 divided by 5 is 2, so it simplifies to be 2 root 5. Okay, below that, let's take 6 over root 5 minus 2. And let's rationalize that, multiplying the top and bottom by root 5 plus 2. Good, so let's distribute the top. 6 root 5 plus 12 all over 5 plus 2 root 5 minus 2 root 5 minus 4. Good. So those middle terms cancel. We get 6 root 5 plus 12 all over 1. And that 1 is unnecessary. 5 minus 4 is 1. So now we can take our parts and bring them back in. So because 10 over root 5 was simply 2 root 5 minus open bracket 6 root 5 minus plus 12. Good. So now we can distribute that negative. So we're going to have 2 root 5 minus 6 root 5 minus 12. We're going to have negative 4 root 5 minus 12. Circle our answer. So that question, we rationalized the denominator and then added or subtracted. You could have, for example, added fractions, getting a lowest common denominator of whatever it is, and then going for it that way. You might have to rationalize the denominator at the end. There's going to be all sorts of different ways to do these types of questions. Just make sure you choose one that you're most comfortable with, or the one that your teacher tells you to do, and then go with it, and then check your answer by typing the question into your calculator, typing the answer into the calculator, and making sure that they're the same. Okay, we have question number 9. Graph, state the domain and range, and find any intercepts of y equals root x. You want to get a closed bracket after that 9 period? Yes. Good, so we're going to graph this. How on earth are we going to graph this? With a table of values. So let's make a table of values off to the right. Let's say x and y. And let's say negative 2, negative 1, 0, 1, 2. So let's take the first value and substitute it in. Back to the left, y equals root negative 2. Can we square root a negative? No. We're going to get no answer there for negative 2, dne, and negative 1 will be dne as well. So the next one will be 0. Y equals the square root of 0. The square root of 0 is 0, so we can put 0 in the table. Then we can do 1. Y equals the square root of 1, which is 1. And we can put 1 in the table. Now, do we know what the square root of 2 is? No. Cross it out. We don't want to do 2. What do we know the square root of? We know the square root of 4. Square root of 4, y equals the square root of 4 is simply 2. And we can put these points on a graph. So notice it's going to be a graph. It's going to be an L graph because we have no negative values. So we can say 0, 0. We can say 1, 1. And we can say 4, 2. And we can draw a root graph. Notice it's a parabola on its side. Let's draw a dotted line of the parabola on the bottom, completely symmetrical, and scribble it out. That would be negative root x. This is root x. There's a whole chapter in grade 12 on drawing this graph, and I just wanted to start to get us thinking about what the square root of x looks like on a graph, reminding you we graph things with a table of values if we forget how to graph stuff. Okay, so number 10. I'm just going to talk for a second. So we don't really make up equations for word problems in radicals because it's too difficult to know what the equation is. So they usually just give you the equation. Here it is. So v sub f equals square root 2ad. So this is an equation from physics that allows you to figure out the final velocity if you know the acceleration and the distance that something traveled. So it says, find the final velocity, v sub f, in meters per second if a car travels from rest 100 meters accelerating at 2 meters per second. Okay, so v sub f equals square root of 2 times 2 times 100. Okay, so V sub f equals the square root of 400, and V sub f equals 20 meters per second, which means that if a car travels from rest, starting at rest, for 100 meters, accelerating at 2 meters per second, at the 100th meter, they will be traveling at 20 meters per second. Okay. Okay, we have number 11. So we have d equals 1/2 at squared. And beside it, we have v equals at. Now this time we're going to summarize the information off to the right. So it says find the time, t in seconds, if a car travels from rest a distance of 100 meters. Off to the right, d equals 100 meters. Accelerating at 2 meters per second, 2 meters per second squared equals a. Find the final velocity vf. So we're going to start on the equation on the left. So we can say 100 equals 1/2 times 2 times t squared. Now on the right hand side we can cancel the 2's. 1/2 times 2 is just 1, so we can say 100 equals t squared, and then we can square root both sides. We'll get t equals 10. We don't have to consider the plus minus because we can't have negative time. So now we'll take the equation v equals at and rewrite it down below, v equals at, and substitute into it. So we have v equals our acceleration of 2 times the 10 seconds we're accelerating, and v equals 20 meters per second. Notice very similar to the question before, given completely different formula. If you're going to be taking physics, these are your physics formulas and they're all related. Notice how we got the same answer doing something completely different. Okay, we have number 12, find the volume. So we have a right angle triangular prism, and we have a horizontal of 4√6. We have a side of 5√8, which is the height of the prism, and we have the height of the triangle being 3√2. So the formula for the volume of this shape is going to be V equals area of the base times h, height. Now, what is the shape of the base? Well, it's a triangle. Let's shade the triangular base. And off to the right, we can find that. So that's A equals BH over 2. So we can say A equals 4√6 times 3√2 all over 2. So we can cancel. We have 4 over 2, so we can cancel the 4 and the 2 and replace it with 2 on the top. Down the page, we can say A equals 6√12. We can now further simplify it to be A equals 6 times 2√3. And then we can say A equals 12√3. Now we can take that, we can bring it back into the question. V equals 12√3 times 5√8. 12√3 times 5√8. Awesome. So now we can do that. So now we have V equals 60√24, and then we can further simplify. V equals 60. And then if we simplify √24, that'll be 4 times 6, so that'll be 2√6. And then we can further simplify. V equals 120√6, and let's say meters cubed. And circle our answer for the final volume. So remember, when you're doing parts of things, it's very helpful to do those parts of things way off to the right and then bring them back into the question. Okay, we have number 13, find the expression for the volume. So let's start by drawing a rectangular prism. And the base, length is 3/4 x, and the other base length is the square root of 8x cubed, and we have a height of root 4x to the 5. Okay, so our volume formula is going to be V equals LWH. Therefore, V equals 3/4x times the square root of 8x cubed times the square root of 4x to the 5. Close bracket. So let's start by multiplying the roots together. So we have V equals 3/4 x times 32x to the 8 square rooted. Good, so we can simplify this. So we have the square root of x to the 8, so we have 3/4 x. Now if we simplify root 32, that's 16 times 2, so that's 4 root 2. And then the square root of x to the 8 is simply x to the 4. So we can bring everything out in front, so we can cancel. We have a 4 on the top and the bottom we can cancel. We're left with 3x to the 5 root 2 centimeters cubed. Don't forget your units, bringing your units back in. So that's a simplified expression for the volume. We can circle our answer, and we are good. Okay, we have number 14. So we have a square with an equilateral triangle on the inside. Let's tick all of our equal lines and on the outside of the square. Yep, exactly. Okay, so it says find the perimeter of an equilateral triangle inside a square with an area of 72 meters squared. Off to the right, let's say A equals 72 meters squared. So if that's the area of a square, how do we find the length of the square? Well, we just square root it by definition. So we can say S equals, for the side length of the square, square root 72. So we can simplify that. So we know that 72 is 9 times 8, so it'll be, 72 is going to be 36 times 2, so it'll be 6 root 2. Good, so that's the side length of the square that we just figured out. Now we have to find the perimeter of the equilateral triangle, which we're just going to know we have 3 sides. So we're going to say 6 root 2 plus 6 root 2 plus 6 root 2 equals 18 root 2 meters. Circle our answer. Great. Okay, number 15, the period of a pendulum, the period T of a pendulum related to its length L is capital T equals 2 pi, then we have a 2-line root, L over 10, L over 10, 2-line root of L over 10 from the question. So it says find an expression for the, can we erase that T on the left-hand side and turn it into a nice capital T? Exactly, perfect. So it says find an expression for L. So we need to get rid of everything attached to L. We're going to start by dividing both sides by 2 pi. Over 2 pi, over 2 pi. So on the left-hand side, we have T over 2 pi equals a 2-line root, L over 10. To get rid of a square root, we simply square both sides. So on the left-hand side, we're going to have T over 2 pi all squared equals L over 10. And then we can times those sides by 10. And we can mirror it. L equals 10, open, T over 2 pi, close, squared. So let's circle that answer. So that's our expression for L. You could start squaring stuff on the inside of the brackets, fine, but we're just not going to. Now they're saying find L if T is 1.4. Off to the right, capital T equals 1.4. Now let's very carefully substitute 1.4 in for T. L equals 10 open, 1.4 divided by 2 pi close bracket squared. Now, in red pen, let's put brackets around only the 2 pi. Good. That's how we're going to type it into the calculator exactly. 10 open, 1.4 divided by open, 2 pi close, close, all squared. Down the page, L equals 0.49. So that is going to be our answer for the isolated length of the pendulum. Great. Okay, so we have number 16. We have a square with a circle inscribed. Now, a circle with an area of 24 pi, let's say A equals your 24 pi, putting it right in, is the area of the circle. Now they want the diameter of the circle and the perimeter and area of the square. So let's start off with the diameter of the circle. So we know the formula for area is A equals pi r squared. So we can carefully take 24 pi and put it in for A. 24 pi equals pi r squared. Let's carefully show the step of dividing both sides by pi and canceling the pi's. And we're left with 24 equals r squared. And let's square root both sides. And r equals root 24. And we can simplify root 24. Root 24 is 4 times 6, so it's 2 root 6. And that is our simplified version of the radius. Remember, in order to find the diameter, we have to double that. So let's say 2 times that. Equals 4 root 6. So D equals 4 root 6. Let's circle that answer. So now we know the diameter of the circle. That is the side length of the square. So now we can say A equals LW. Therefore, A equals that times that. A equals 4 root 6 times 4 root 6. And therefore, A equals 16 times 6, and 16 times 6 is 96. So we can get our units in there, centimeters squared. We can get our units in there, centimeters squared. We can circle our answer, and now we have to find the perimeter. P equals 4 root 6 plus 4 root 6 plus 4 root 6 plus 4 root 6. Nice work. Therefore, P equals 16 root 6 centimeters. Circle our answer. Awesome. Okay, we have number 17. This time, we have a square inscribed in a circle. And it says the diagonal length of the circle is 2 root 6. The whole diagonal length of the square, is 2 root 6. Good. And we're going to find everything, the perimeter and area of both the circle and the square. So let's start off with the square. Let's draw that right angle triangle all by itself, separate. And let's put 2 root 6 on the hypotenuse, and let's label the two side lengths x. So beside it, let's say Pythagoras' theorem. Let's go beside it. Yeah, x squared plus x squared equals brackets around it, 2 root 6, all squared. On the left-hand side, so that's just a squared plus b squared equals c squared. On the left-hand side, we have 2x squared equals 4 times 6. So we get 2x squared equals 24. We can divide both sides by 2, and we have x equals root 12. X squared equals 12. We can square root both sides, and we'll get x equals, hang tight, 4 times 3, 2 root 3. Circle our answer. So that's x. So to the right where we have a little bit of space, let's go for a equals LW, maybe at the top. A equals LW, this is going to be of the square. So a equals 2 root 3 times 2 root 3. So a equals 4 times 3. So a equals 12 meters squared. Circle our answer. Notice we forgot to say meters beside x down below. Meters. Good. So now we're going to figure out the perimeter of the square, and we're going to do it simpler. We're not going to add it 4 times. We're just going to do it times 4. So we can say, let's do it to the right. P equals 4 times 2 root 3. Because we have 4 sides that are each 2 root 3. Therefore, P equals 8 root 3 meters. Circle our answer. Okay, now for the circumference of the circle, or the perimeter of the circle, we can say C equals 2 pi r. Now, if the full diagonal of the square is 2 root 6, then half of that will just be root 6. So to the right, let's say r equals root 6. Simply taking the full diagonal and dividing it by 2. So C equals 2 times pi times root 6, which is simply just that. C equals 2 pi root 6. Meters, circle our answer. So off to the right, let's say A equals pi r squared. Down the page, let's say A equals pi open bracket, root 6 close bracket squared. A equals 6 pi meters squared. Circle our answer. Let's go.